So let's do a little task with dictionaries, and then let's turn it into a class, and then we'll take a blind stab at trying to get a graphical user interface going with it. But if it starts to go awry, we'll just go, whoa, Nelly, and we'll go on from there. So what I'm thinking about doing is, you're used to the idea like of rolling 2 dice, and you can get any numbers between 12 and 2, right? And you get more 7s than you do 12s or 2s because there's more ways for the numbers to add up to a 7, right? So like if you're rolling 2 dice, you only have a couple of options that can roll up, to get a 2. You essentially have all those, and then you have them reversed, right? Out of all the options that'll add up to 2, it's only that one and that one. And if I kept on going, right, we could show that there's only 2 ways to roll a 12. That's when you roll a 6 and a 6 in either order. But there's a lot of ways of adding up to 7. There's 1s and 6s, and there's 2s and 5s, and there's 3s and 4s, right? And then there's 2s and 1s, and, whatever. So that's called a bell curve. When you have something that occurs very small on the ends, and then it occurs very large in the middle. So what are we going to do? We're going to use a dictionary to hold the result of random numbers, 2 random numbers, 1 to 6, added together, to see which number comes up the most often, just like rolling 2 dice. And it ought to be 7 if we've done it right. Looks like we're on T. All right, firstly, let's just make sure that we know how to generate the random numbers. Because I always have to look it up, right? We always have to import the random library. And then we can usually do something like x is equal to random dot, is it random int? Is it RND int? I never can remember.
I think it's randint.
Randint with a space or no space?
It's random, or yeah, randint.
Randint like that. And then you put a 1 and a 6. And then a y is going to be the same thing, right? And then the total of those things, and let's just shorten it to t, is equal to x plus y. And we could print t. Let's just make sure that that looks good. Okay. Of course, the fact that I have the word lecture T up here is going to be a real pain. There, now it has a chance of working. All right, and so whatever it rolled added up to a 10. We could print them out, right? X, comma, quote, plus end quote, comma, y, comma, quote, equals end quote. Those are supposed to be quotes, not bars. Equals, and I'm going to add some spaces to make it a little clearer, right? Don't know if that makes it clear or not. You don't have to have all those spaces. You don't have to have any spaces at all. I'm just trying to make it easy for you to see. Run it again. And 4 plus 5 is 9. Good enough. Now what are we going to do? We're going to loop, doing that like 10 times or 100 times or something like that. For loops are pretty cool. Let's do a for loop. So up above the x and the y business, I'm going to wind up tabbing these 4 lines over, so I may as well do it even before I type anything else. So grab your 4 lines there. And if you're not done typing anyways, pay attention that we're tabbing those 4 lines over now. And then we're going to put our 4 up at the top, like I, for I in range. How many times are we going to do it? 10? 10. Colon. And there we go, right? It generated 10 numbers that were the product of 2 random numbers from 1 to 6, like rolling 2 dice. We can already kind of see that we hardly got any 2s. And well, this wasn't enough rolls for us to get any kind of pattern going on, really. Because these patterns, these curves, show up when you roll a lot of dice, right? So we're going to need a dictionary to hold our results, where the key is going to be the number that was rolled, and the value is how many times it was rolled. We did this with letters previously. We were stepping through a series of letters, and each time we found an A, we incremented the A place in the dictionary, and so on. So, everybody got this part working? If not, summon me and let me help. Alrighty. Okay, so I'm going to call this rolls. Rolls Royce, huh? Rolls is equal to, and I could do dict, parentheses in parentheses, or I could use the curly braces, whichever notation you like. Dict, parentheses, parentheses is probably easier to read, so we could go with that. So what do we need to do next? We need to see if that element, if this roll is in our dictionary. And if it is, great, we just need to add one to it. But if it's not, we need to create one. So if T, our total, in space if it's in the in rolls, colon, great. In that case, rolls subscript T in subscript plus equals 1. Else it's not there. So else, colon, rolls subscript T is equal to 1. It's the first time we found it. Roll subscript T equals 1. And all of that needs to be tabbed over appropriately to be inside the for loop. Lastly, let's just print the dictionary with a single print statement. Print parentheses rolls. That'll be enough, right? We're going to make it look better after a while, but that'll be enough. And there we go. We rolled an 8 one time. We rolled an 11 3 times. This is looking pretty weird. A 9 one time, a 4 one time, a 6 2 times, and a 12 2 times. That does not make any sense if we were going for, 7s more often than anything else and 2 and 12s least often. But Lisa seems to be saving some data. I need to back up for a moment and remember how we got our data sorted by the key. I don't remember it being real complicated, but I want to make sure that I do it right so I don't fumble. So allow me to go into our notes. Heck, it's probably right here inside. Bet it was lecture Q or R. Here we go. So in lecture R, there's a little bit of code that will allow us to get the data from the dictionary sorted by the keys. I'm just going to copy that, paste it so that I can use it as a reminder of what I need to do. You don't need to type this in because that's just a reminder for me to remember how to do it. Okay, so oops. We don't want to print the rolls out in that format. That's kind of lame. Instead, we want to print them out. So, for key, can I type? For key in sorted, in space sorted, parentheses, rolls dot keys, parentheses in parentheses, colon. Let's get the value of the key. Value equals frequency. No, it's not called frequency, is it? It's called rolls, parentheses, key, in parentheses. And we'll just print those two numbers out.
Keys or key?
Key, because our counting variable is called key there. We could just call that T instead, because that's what it was before. Let's do that. But remember that the first thing in the dictionary, it has two pieces, right? It has this, which is the key, and it has this, which is the value. We were calling the key t up here, so why not be consistent down here? And so we're going to print out the value. Well, let's print out t and then the value that's associated with it. And if it works, I'll delete that comment. All right, there we go. Right, it rolled a 3 one time, it rolled a 5 one time, it rolled 6 2 times. If we crank up and do 1,000 numbers, the law of averages is going to start to kick in. Of course, it's going to take a while to do 1,000. We might want to comment out that print statement. I don't need to know all these intermediate things, right? Yeah, comment them out. Let's comment out this print statement right here. You see that print statement? I'm commenting it out just to speed this up. And there we go, right? Ooh, that was fast. We can see that we rolled a 2 only a little bit. We rolled a 7 a whole bunch. And we could convert these to percentages just by dividing them by the total number of rolls, right? If we rolled them by 1,000 and then we rolled them by, divided by, 1,000, we'd get some kind of percentage. Let's see if we can get that to work. I'd like to see them as percentages. Whoops. That shouldn't be too hard though. So to turn that value into a percentage, I think we divide it by the total number of rolls, which was 1,000, and then we multiply it by 100. So in effect, we're just dividing it by 10. But let's be awesome and cool and change this 1,000 to a variable. Like if we wanted to ask the user how many times to roll. I'm going to call this num underscore rolls equals 1,000. And then I'm going to put that num underscore rolls inside my for range statement. That's just so that I have that number later. So when I want to calculate the percentage, I can easily get it. And if I ever changed it to 10,000 or a million, I won't have to change it in 2 places. So you see what I did? I just added this line, and I changed the range statement to say that. So value we're going to turn into a percentage. So value equals value divided by num underscore rolls times 100. Right? That's how you calculate percentage. And I can delete this junk. Don't need to comment anymore. Alrighty. It's showing that we roll almost as many 6s as we do 7s. Still not very bell curve-ish. Let's crank it up so that we do it 100,000 times. I'm going to add 2 more zeros to my num rolls. All right, now it's starting to look like the bell curve that I'm expecting, right? Only less than 3% of the time do we get a 2 or a 12, but almost 17% of the time we get a 7. We could draw this as a little bar graph, right, made by the number of asterisks. For every number in there, we print out an asterisk. That might be fun. Let's do that. What I'm going to do is I'm going to take this for loop and copy it. Just grab the whole for loop and copy it. But comment out this print number, this print thing right there. Or delete it, right? Delete that print statement because we're going to replace it with a for loop. Let's print t, which is the number. So print t, comma, end equals, quote, space, quote. We're doing that so that we won't go to the next line because then we're going to print a bunch of asterisks representing the number of times it was rolled. So print parentheses t, comma, end equals, quote, space, quote, in parentheses, and I'll do walkabout in just a second after I write the for loop. for x in range. And now you may have noticed that you have to convert a number to an int to use it in a range. int t close parentheses, colon, print an asterisk or a hash or whatever you think would make a cool looking bar chart. How about a hash? So parentheses, quote, hash, end quote, comma, end equals, and then just two pairs of parentheses, no space between them even, like that. And then a close parentheses. And after the for loop is done, we need to print one more carriage return to get it to go to the next line. So print parentheses in parentheses. Let me make sure I don't have any syntax errors. Well, that didn't work. This actually should have been for x in range value. I'm sorry, so sorry. You see that line there? That should have been int parentheses value, because we don't need to print the key out. That's just printing the numbers 2 through 12. We need to print the value, right? It rolled it 7 times, it rolled it 9 times, something like that. So change that t there to the word value, and we should be good to go. And there's our little bar graph. So that's another example of using a dictionary. One of the projects is to use a dictionary and you open a file, you read the file in, and you count how many each time a letter occurs, and then you print a bar chart based on that, a bar graph based on that. And on Tuesday, we demonstrated how to draw a bar graph using turtle graphics. But here's another way, right? Either way would work. We should add some comments. I'm going to add a comment here. That's not a comment in this language, sorry. Value equals number of times I'm not liking the way that's being worded. How many times this number was rolled. And this is convert value to a percentage. That's what those two things do. And this go through our keys, which is probably 2 through 12. But if we changed it to roll 3 dice, then your values are not going to be 2 through 12 anymore, right? Because rolling 3 dice, you could get a 3 all the way up to 6 times 3, which is 18. How would we do that? We just generate a new random number up here. If you feel like going crazy, add z equals random.randint and make t equals to x plus y plus z. See if it works. Just add one more thing here. Add a z equals random.randint and then add x plus y plus z there, and then make your bar graph. Yeah, y'all go ahead and try that while I'm wandering around helping. All right, so I'm going to add a little bit more up here where it says y equals random. I'm going to copy paste that and make it say z equals. La-di-da. You know, and we could use a loop to add these up, right, so that we could roll 10 dice, right? There we go. X, Y, and Z. And then there's a useless little comment there, right? I'm going to change this to say t equals x plus y plus z. So I just changed this line. Never add these things. This is there just for you to notice. I'm going to totally delete that one. I'm tired of looking at it. All right, now to go. Now it's rolling 3 dice rather than 2, so the range should be 3 to 18.
What if you want to change it? Oh, never mind, I already know.
And that's a real nice looking bell curve. Now this looks lame, right? We should make each one spaced out 2 times, and we could take the time to do that, but you know how to do that. You do that quote, %2D, end quote.
When you say spaced out 2 times,
what I mean is the bar graph starts on this column here, and it starts on this column here. So this guy.
Oh. Okay.
So we just need to do that %2D business.
You want to move them out of
right, or
so
%3D.
Oh, okay.
Let's go ahead and do that just to make it look nice. We're going to come down here in this line that says print t comma end. We're going to make this part more complicated right there, just because that's how we roll. Right before the t, do quote %3D end quote, and then another %, like that, right? Or if you want it 4 spaces wide, make it 4D. You want it 2 spaces wide, 2D. Now it's looking a little better, right? Apparently we never rolled any 3s. We never rolled any 18s. Oh, we did, but just less than 1%. And our stuff is rounding down rather than rounding up. How do you round up? Do you remember that there's a floor command and then there's a ceiling command in the math library?
Yes.
Let's see if I remember how to do it. I'm going to do import math, and then I'm going to say underneath here, I just added this line, I'm going to say value equals math.ceil parentheses value. And I hope that works. I'll have to Google it up if it doesn't. Yeah, okay. So what does ceiling do? It rounds to the top, always. Doesn't matter if it's 2.5, 2.1, or 2.9, it gets rounded up to 3. And that way, if something is less than 1, we still see it as 1. Yeah? So that's a real pretty chart. I'm pretty happy with that. Anybody need eyeballs on the screen to get this fixed? We just added this line, and we just added this line. Now that we have this stuff, we don't need that I and T anymore. It doesn't hurt, but math.ceiling probably converted it to an integer, but I'm going to leave it alone. I'm going to leave it alone. Because if value was still afloat, it would crash on that line. I'm not sure that this is a good example of turning into a class or not. So let's come up with something else that would be good to fit into a class. A box is a height and a width and a depth. It's going to be very similar to the last one, but we're going to make an important change to it. So we're going to define a class called box. And I made it a capital B. So when I create my boxes down underneath it, I'm going to have to remember that it's a capital B. So class box. Now I need to make what's known as that constructor, that init method. And remember that it's going to use 2 underscores on each side, just like that main business does whenever we do it down there at the bottom. DEF underscore underscore INIT underscore underscore parentheses self. We're going to make this one a little bit more interesting in a minute, but for now we're just going to close that self colon and say x equals, self.x equals 1, self.y equals 1, and self.z equals 1.
These are the defined variables?
Yep, those are the variables that are part of the box class. So just like last time, let's write a get area method, or get volume, excuse me, which is x times y times z. So define, or DEF, get underscore area, parentheses self. Every function, every method that you add to a class is going to have self as the first parameter variable between the parentheses. Colon. And what is area? area is equal to self.x asterisk self.y asterisk self.z, and then we can return the area. And let's write a print function that prints information about the box. def print parentheses self in parentheses colon. Let's get the area. So area equals self.get parentheses area in parentheses. Wait, what am I doing there? Self.get underscore area parentheses in parentheses. And then let's make a string to print. Print parentheses quote box %d %d area equals %d. I shouldn't be using d's. Those are integers. Just know that it's not going to work if you use a floating point value. End quote, followed by a percentage and then a tuple containing 4 values. So percent parentheses and then 2 close parentheses, and in there we need to fill in each placeholder. The first one was going to be the value of x, the second one's going to be y, the third one's going to be z, and the fourth one's going to be area. So this dot x, comma, this dot y, comma, this dot z, comma, area. Just about scrolls off the end again. I'm going to remove the spaces around area just so it all fits on one line visibly. Okay, let's make some boxes. Back tabbed all the way against the back margin. Box B1 equals box parentheses in parentheses, and these are all with a capital B if you made this one with a capital B. Box B2 equals box parentheses in parentheses. And when we call print, it's just going to say it's a 1 by 1 by 1 box. P1.print parentheses in parentheses. Why did I say P? B2.print parentheses in parentheses. And it should print out that we have a 1 by 1 by 1 box with an area, and that should have been volume. I don't know what I was thinking of. The area of a box is a completely different formula. If you don't mind, go and change the word area there to volume. Maybe just VOL. Change it there too, VOL. Change it there again, VOL. So I had to change all 3 lines here. 1, 2, 3, change area to VOL. And do the same thing here. You got to change that one. Sorry about that. Change, and don't add these comments. You know what they're for. And then there's 2 more places here. VOL there and VOL there. By the time we're done, the word area is not going to appear anywhere in our code. VOL and VOL.
So we change.
And there. Absolutely every one of these areas need to be replaced with VOL. To the point where if you do Control F and look for the word area, okay, well yeah, that's legit, right? But it's in a comment. Okay. Yes, sir, Dev? You were asking?
All the areas are changed to vol now.
Right, right.
Okay.
Invalid syntax. That's because you don't prefix your variables with a data type in this language, unlike C++ and Java and stuff. So, my mistake. We're going to have to delete 2 little things. right here, delete the word box in front of the variable name. You do have to declare your variables in other languages. You may have seen like int space x equals 3 or something like that. In this language, you don't. So now it just says b1 equals box, parentheses in parentheses, b2 equals box, parentheses in parentheses. All right, I was totally spacing out. I can't believe I did that. All righty. If our variable here is called self, the variables here need to be called self as well. It's in Java that they call it this. Inconsistent. I could fix that by changing that word right there to this, or I can change it by changing these three thises to selves, which is what I'm going to do because it looks more Pythonese. They use the word, the vast majority of programmers seem to use the word self there. So this needs to say self.x, self.y, and self.z. And there we go, right? A 1 by 1 by box is, in fact, got a volume of 1. What if we wanted to change it? What if we wanted to be able to do this? This is what I want to be able to do. It's not going to work. Don't make this change if you haven't typed in the rest of the code yet. But I want it to be able to work like that. That's a 2 by 3 by 4 box, and this is a 10 by 10 by 10 box. If I want that to work, I'm going to have to change the constructor up here, and then change these 3 lines as well. So before I do that, I'm going to pause and make sure we're all caught up. All right. So what we're going to do is we're going to make it so that we can pass in 3 values like this. So we're going to come up here and we're going to say, after that self in this line, we're going to start accepting more arguments than what we have. So we're going to add 3 parameters here. Comma x, comma y, comma z. And we're going to change these 1s into x and y and z. So what does that mean? That means that when we call the creator, the constructor, the init method, that x gets filled in with 2, y gets filled in with 3, and z gets filled in with 4. And then those variables get added or assigned into self.x, self.y, self.z, the 3 members of this class. There we go, right? And a 2 by 3 by 4 box is 24, and a 10 by 10 by 10 box has a volume of 100. So we just changed that line. We added the x and the y and the z there. We added these 3 lines, and then we changed these 2. So these are the 4 lines that changed up here, and these are the 2 lines that changed down here. We can also access those variables directly, where it says x, y, and z. There's nothing stopping us from accessing them. If you program in another language called Java or C++, you can make these variables so-called private, meaning that we can't do what we're about to do. But in this language, there's nothing to do, nothing to stop that. So if we feel like saying b2.x equals 99, and then we feel like saying b2.print, so I just added these 2 lines, that's okay. We're just changing the x variable, which changes self.x. So self.x is going to equal 99. So when we calculate the volume, we're going to get a different answer now. Like that. And we could change b2.y and b2.z similarly. All right.
What if you wanted to ask for input from...
Yeah, we could certainly ask the user to substitute these values. Right? So I'm going to get rid of these 2 things b2.x is 99 and b2 print. Let's make a brand new box. b3 equals box, and it doesn't matter what size it is, but we could ask for the sizes beforehand, right? Like height equals int parentheses, input parentheses, quote, what is the height of the box, question mark, end quote, in parentheses, and that's a lot of typing, so I'm just going to copy and paste it. And I'm going to make it say height, width, and depth, so H, W, and D. And I'm going to change these words, height, width, and depth. Now when I create the box, I need to pass those three variables in. I need to make it say box, parentheses, height, comma, width, comma, depth. And it's, what's the height of the box? I forgot to add a print statement, so after I type that stuff in, it's not going to show anything. So I'm going to do that right now. b3.print, like that. So the height of my box is 5, the width of it is 6, and the depth of it is 2. Oh, look at that. What'd I do dumb?
Box is a capital.
Box has got to be capitalized. After I warned y'all to watch for that. That needs to be an uppercase B right there. Height of the box 5, width is 6, depth is 7. All right. That make sense, Clarence?
Mm-hmm.
All right.
I just gotta type.
Now we're going to have to type that stuff in every time we run it, but we might wind up commenting it out, right? It's real easy to comment it out. After you've tested it, you just put 3 apostrophes or quotes up here, and then 3 down here, and we're all good. Not 4, like I just typed. All right. All right, designing with functions. Good news, we've been writing functions since day 1 pretty much. We already know how to do this stuff. Explain why functions are useful. Employ top-down design. And define a recursive function. Okay, well a recursive function is just a function that calls itself. I'm going to give a 30-second demonstration of a recursive function. I'm going to come into our code, and down here at the bottom, I'm going to define a function. I'm just going to call it REC because it's recursive. So DEF REC, parentheses in parentheses. And let's print something. Print, I am recursing. End quote. Yeah, I need my colon there. Thank you. And then we're going to call ourselves again. Recursive, right? That's an infinite loop, except it's worse than an infinite loop because it'll crash. Why will it crash? Because each time a function is called, it has to allocate a little bit more in memory to understand where it is. And each time it returns out of that function, it releases that memory, but this thing never returns, right? It keeps calling itself. Like I said, you know, go back to start, but in this case, the go back to start is actually making the function call to itself. So it's keeps running into itself over and over and over. So if we add this recursive like that, we're just going to see the message, I am recursing, and if we let it run long enough, we'd see it crash. I don't know how many times it would take. We don't have a counter going on, so it's real hard to check, right? But we could add a counter to it. Let's make it so it takes a number. We're going to pass in 1 here. We're going to make a parameter variable to accept that argument, so I need to put an X there. When I print out I am recursing, I'm going to put a comma X here. And when I call recursive, I'm going to add 1 to it. So it's going to say I am recursing 1, and it's going to say I am recursing 2, and it never returns out of it. like that. It's just going to go forever until it runs out of space, runs out of memory. And I don't even know how to let it run long enough. Maybe if I minimized it, maybe it'd run more quickly, right? Because that's what takes up the most time. Maybe if I minimize it and then let it run for a while and then come back to it. So it crashed yet?
979.
979. Yeah. So it was able to call itself 979 times. It's kind of like a magic trick. The rabbit crawls into the hat, and then it pulls the hat into itself, and then crawls into the hat again, and then it pulls the hat inside the hat, and then keeps doing that over and over and over until it's done it 979 times. That's recursive programming, when a function calls itself. Now, you could ever write it like that? No, that's dumb. But recursive functions do have a purpose in computer science. They can implement some things well. For one thing, they can implement almost anything that a loop does, but you can see that it's kind of a brain bender, and if you don't have to do a recursive function to handle a loop-like function, then you would want to avoid it. But let's give it a shot. We're going to write a recursive function which adds up all the numbers 1, 2, 3, 4, 5 like that all the way to 10, something like that. Now normally we'd use a loop to do that and it'd be real crystal clear. But we are awesome now, so we're going to write it recursive and it's going to be less clear. So define sum, which is going to stand for summation. I'm putting 2 m's because there already is a sum function with 1 m. And it's going to take a value. And we need to check. What it's going to do is when we pass in 10, I'm going to come down here and do this. Total equals sum, like 10, like that. I just added that. So when we call it first, x is going to equal to 10. But then it's going to call itself again. It's going to add 10 to itself and then subtract 1 from 10. So then it adds 9 and 8 and 7 and so on. So it's a problem if x is less than or equal to 0. We're going to return 0. Else, colon, we're going to return x plus summ parentheses x minus 1 in parentheses. See, it's going to call itself. The first time it comes in, x is 10, so it's going to return 10 plus a summation of 9. And so it's going to run up here, and x is going to 9, and so it's going to come up here and print 9, or return 9 plus a summation value of 8, and so on. And so it's going to keep going into itself over and over and over until x is finally less than or equal to 0. And then it's going to return, and it'll be able to return the value all the way back out to here. And I forgot to print it out, and I really don't want it recursing over and over and over anymore. So we've seen this, we've enjoyed it. I'm just going to comment these 3 lines out, and I'm going to comment out where we call it, because we're done with that. I don't want to wait 979 times for it to crash. And I still forgot to print the total out. So the last thing. Print, parentheses, quote, total summ, parentheses 10, in parentheses, end quote, comma, total, end parentheses. Yeah. And it is true that the summation of 1 to 10 is 55. What if we made it the summation of 1,000? It's going to crash. Why? Because we've already proven that it can only go into itself 979 times. So can it go into itself 1,000 times? No. Maximum recursive depth exceeded. But we could probably do it 900 times. Summation of all the numbers between 1 and 900. Yeah, okay. So, if we had implemented this as a loop, would we have had to stop at 900? No, we could have added as many numbers as we wanted. So why did we implement it as recursion? Just to show you that it could be. Loops can be implemented as recursive functions, but They're a little bit of a brain bender, and I would never do it unless I absolutely had to. So when would you use recursive functions? Sort algorithms. Some sorting algorithms rely on recursive functions and are able to handle the data. Like there's something called quick sort, which is one of the fastest sort methods possible, although there are faster ones. And it uses recursion in order to figure things out. So it's a useful concept, and now you've seen it, and I'm never going to ask you to write a recursive program. When you write a recursive program, you always have to have two things in here, or else it's going to be broken like this. There has to be something that is called the base case. Like a space case, except it's a base case. The base case just returns something, anything. Right? It doesn't call itself. Without this base case, it'll always call itself over and over and over until it crashes. This function up here, this REC function, didn't have a base case, and so that's why it crashed. We could have put an if statement in there, you know, and once x exceeded a certain number of calls, we could have made it return out of it, and that would have worked, but we didn't. And then the second case is the recursive case, when it does call itself. So every recursive function written will have at least one base case, maybe more, and it's going to have a recursive case where it calls itself. And it'll always be set up something similar to this. We could delete the word else and then back tab this over a little bit if we wanted to make it look a little bit different, but I kind of like seeing if else. The reason that would work, let me do that temporarily, but don't let this confuse you. Don't make this change. Why does that work? Why is that the same thing as it was before? It's because if it returns here, there's no way it's going to get to here. And if it doesn't return here, it has to go here, right? So it's the same thing as an else, it's just we took the word else off because we knew that there was only one alternative. If this wasn't true, it has to do that. I'm going to undo those steps, though. I kind of like seeing if else. If you don't, if you like wording it the way that I just did a second ago, you can run with that. Alrighty, I'm going to start assigning fewer homework assignments now than I used to. The reason for that is because I want y'all to start working on your projects. So instead of hammering y'all with 2 homework assignments a week, we may go down to 1 homework assignment a week. And we've already had one for this week. And it was to write a class. And we don't need to write recursive functions, in my opinion, so we're not going to add on to your homework. However, I do want to pause and take a moment to look for something.